Right. Welcome to the Artisan's measure. And I just want to look at a graphic here so that I get this right. Um, yes. And the Artisan's measure was developed thousands of years ago by master artisans to show young apprentices the importance of looking at a process, the importance of developing various resolutions and being shown eventually and led to what I believe is to be a revolutionary approach to resolving what is a deceptively simple problem. And I have already stated this in, firstly, in terms of a written account. I have already stated this in terms of a visual account, and now I will give an oral account. And some people are better at processing information in terms of written account. Some people are better in terms of a visual account, and some people are better in terms of an oral account. So all three are make up the whole package of this particular thing. And what we have is a simple square. I call it a square of slate. And the dimensions on the square are 5 by 5 units. It doesn't matter whether it's millimeters, angstroms, it could be meters, it could be kilometers, it could be whatever else, whatever the units are, millimeters, centimeters, meters, 5 by 5 units. And we have a rule. A ruler is a king, a rule is a measuring rod. I was told this once when I was explaining this by a master or to a master artisan who was a mechanical engineer who had an interest in furnaces, and much like what my son is doing at the moment. So a rule is a measuring rod, a ruler is a king. And you have a scribe. When I was designing this particular process, I rang a company that had inscribed or scribed, had done facing for a building in the University of Limerick, and I rang them up and I found out who the company was, and I was told that the tool that they used to score a piece of slate prior to cutting it, is called a scribe. So you inscribe or you score. And the object is to design the process so that you can score 6 parallel lines on a piece of slate so that you can cut the slate into 7 parallel or equidistant slices. And that's it. That's the statement of the problem. You have a 5 by 5 piece of slate. You have a rule which has 6 tick marks on it, and each of the tick marks are equidistant, and they divide the rule into 7 equal parts, and you must resolve the design process yourself. And it's still working. Okay. And there is a little clue in AM2 and AM3 as to what the solution to this particular design process is. Now, I have talked with a number of people face to face about this, and I have talked with a number of people or chatted with a number of people online about this. I'm not going to give the answer just yet. I prefer to develop a little bit of interest, and anyone who follows this should put their comments or put their chat or whatever else in the comments. I prefer not to comment on this in individual chats. I prefer to comment on this in terms of comments in Arab Fusa. Arab Fusa is the fast enumeration, and this is a particular problem which I believe cannot be resolved using mathematical logic. You need to use a computational process, and as I say, the resolution is truly revolutionary. Cur is the Irish word for revolution. Cur casa an bóthar, the turning of the road, and that is another little clue. Cur casa an bóthar, cur casa an toas, the turning of the measuring rod, turning of the measurement. Sinné, gur maithagad agus slán. Just in case you're wondering why I'm looking that direction and not straight at the camera, is because I have a computer that has a separate screen. So